Okay, 5.5 day one, solve quadratics by factoring. There we go. The standard form of a quadratic equation is ax squared plus bx plus c equals 0. This should look familiar, just a little different. Who can tell me what's a little different about this? The equals 0 part, that's the new part. Before, we didn't have these as equations. They were just expressions. They did not have an equal sign. Now they do. Once we add in an equal sign, that means we can solve it. All right, once a quadratic equation is in standard form and factored, then you can use the zero product property to solve it. The zero product property is a very fancy math way of saying that for two things to multiply to be 0, one of those things had to be 0. So if you multiply A and B and you get a 0, then either A had to be 0 or B had to be 0. An important thing to remember when we're doing these problems is that the equation needs to equal 0 first. Otherwise, it's not going to work for us. So on the solve side, this has already been factored for us, which is just wonderful. That makes our lives a lot easier. So we can go straight into using the zero product property. So the zero product property says that if I'm multiplying these two sets of parentheses together and they equal 0, at least one set of parentheses needs to equal 0. So I use that information to set up two equations. Either x plus 3 needs to equal 0, or x minus 7 needs to equal 0. One of those has to be true. Who can tell me how to solve the equation on the left? Dana? Subtract 3, and what do we get for x? Beautiful. Z, can you tell me how to solve the other one? Add 7. And x equals 7. Beautiful. So these are what we think are the two answers for this. But we're going to check ourselves to make sure that we are correct. So when we check it, we go back to the original problem. We are going to see if when we plug in -3 for x, if we get a true statement. And if when we plug in 7 for x, we still get a true statement. So we have two answers we got to check 2 times. -3 plus 3 times -3 minus 7. I'm not giving myself enough room here. We want to see, does that come out to equal 0? What's -3 plus 3? 0. What is -3 minus 7? -10. What is 0 times -10? 0. So did that work? Yeah, we got a true statement. That worked. But we still need to go ahead and check 7 also. We want to make sure both of our answers are correct. So we have 7 plus 3 times 7 minus 7. 7 plus 3? Anybody?
10.
It's 10. 7 minus 7? 10 times 0?
0.
So did we get it right?
Yes.
Yes, we did. They both worked. It's not always going to check out quite that easily where it's like, oh, obviously we're going to get a 0 on one of those both times. It won't always be that easy to check, but sometimes it will be. Questions before we go on to number 2? All right, on number 2, I'm going to take away number 1, so we've got some room here. Number 2 is not factored for us. We have been spending so much time factoring by the AC method with the bottoms up that I think we need to get back to trying some of the other types of factoring. Technically, we could do this with bottoms up. It's just adding some steps that we don't need. When there's not a number except for a 1 in front of the x squared. We can go straight to our parentheses. What's going to go in the front of both of them? An x. What are the signs going to be? Two different signs, plus and minus, because we have to multiply to a negative. We need two numbers that multiply to negative 14 and add up to 5. What are those numbers? Gabby? 7 and negative 2. So a positive 7, a minus 2. Once we get it factored, and so it was set equal to 0, we got it factored, now we're able to split it up into two problems. Who can tell me what my problems are? Z. X plus 7 equals 0 and x minus 2 equals 0. Who can tell me the solutions to those?
Oh.
Sure, Dana.
So for the first one, you want to subtract 7.
Okay. What do we get?
X equals negative 7, and then for the other one, you will add 2, x equals 2.
Beautiful. So we have that x equals negative 7 and that x equals 2. In order to solve it, we are going to go back to the original problem. So we're not going here in the middle, we're going back to the original. So we've got negative 7 squared plus 5 times negative 7. We're plugging in the same x the whole time. Yep, we plug in that negative 7 to both the x's. In a minute, we'll also plug in the 2 to all the x's. But we'll do with the negative 7 first, then we'll worry about the 2. Negative 7 squared.
49.
Positive 49. Negative times a negative is a positive. 5 times negative 7. Negative 35. Minus the 14. So we just need to take 49 minus 35 minus 14. What do we get? 0. So did this work?
Yes.
Yes. So that worked out. So then we go through and we plug in the 2. See if the 2 also worked. 2 squared plus 5 times 2 minus 14 equals 0. What is 2 squared? 4 plus 5 times 2? 10. They're both positive, right, on this one? Up here, the 7 was negative, so that was why this one changed. Here, the 2 is positive. It is 0. 4 plus 10 is 14. Minus 14 is 0. So both of our answers checked out. So to get this set equal to 0, we have to move the 12x. Because it's positive, we move it by subtracting it from both sides. So this side comes out to be 0. Can these combine on the other side? No, I was only hearing like one person answer. Everybody should be able to tell me that those cannot combine. So we just write it as 4x squared minus 12x. If they can't combine, you just string them along. Write them all there with their appropriate signs. Now on this one, when I go to factors, there is not a c, or c is equal to 0. So what do I check for? A GCF. What is my GCF? 4x. Wonderful. What do I get when I factor out a 4x? X minus 3. On problems where you factor out a GCF, if you want to put your GCF in parentheses too, to help you remember that it also gets its own equation, I would do that. If you don't do that, it's not wrong, but you need to remember that this 4x is going to get an equation out of this. So the 4x gets set equal to 0, and the x minus 3 is set equal to 0. The greatest common factor is still considered a factor So it still gets an equation. All right. How are we going to solve the first equation? Somebody other than Z and Dana. I disagree. I just want to leave x there and get it by itself. Divide by 4. What do we get for x? 0. Somebody new, tell me how to solve the other one.
Plus 3.
Add 3 to both sides. What do we get for x? It equals 3. Beautiful. Then we have to check it. To check it, I'm going back to my original problem. So we first plug in 0 for x on both sides. So now we're going to have work to do on both sides. What is 0 squared? What's 4 times 0? What's 12 times 0? Okay, so 0 makes our life easy, right? Both of those are going to come out to equal 0, so they equal each other. Life is wonderful. We move on. Now we have to plug in the 3.
0.
No. Life is not quite that easy. All right. On the left side, what do I do first? The exponent. No. No. Hold on. Apparently we might have a misconception. We need to do our exponent before we multiply. What's 3 squared?
9.
What's 12 times 3?
4. 38. 34. 36.
36. We got there eventually. What's 9 times 4?
36.
Also 36.
Equals 36.
So did it work?
Which equals 0.
No.
So 1.
So that
Did this work?
No.
No.
Does 36 equal 36?
Yes.
Yes. So that means it worked.
Got it right. I never said that could happen.
All right, so to get this set equal to 0, we subtract 16 from both sides. This is a special factoring case that we have not looked at in a while, unless you did the bonus last night.
Bonus.
How do I factor this? 9 is not a common factor.
Square root.
Square roots. This is the difference between two perfect squares.
So 3 and 4.
So there will be a 3 and a 4. What else will there be?
0.
A 0 over here. What else?
Plus. I mean, yeah, minus. Yeah, plus and minus.
Plus and minus. I think I heard one other person say what we needed. The x. Okay, so we came up with that. We constructed that by square rooting both of our terms in the problem. When we square root 9x squared, we get 3x. So that goes in the front. When we square root 16, we got 4. That goes in the back. 1 plus, 1 minus. It's a special factoring pattern. Once we do all of that, then we are ready to set up our two equations. What are they going to be?
9. 3x plus 4 is 0.
3x plus 4 equals 0. 3x minus 4 equals 0. And then we have to solve both of those. Can anybody tell me what they got for x? Or what? Z, you're just carrying the class today. What are we going to get?
Is it just 4 and 3?
X equals 4/3 and
Interesting.
Oh, my bad. It's the same.
we get two different ones.
Oh.
3 over 4.
Nope. Negative 4/3 is our other one.
Oh.
So on the first one, we would have to subtract 4 from both sides, then divide by 3.
So it doesn't work.
On the other one, we add 4 to both sides, divide by 3. We are not ready to decide if these work or not yet.
True.
So we've got our two answers.
Plug them in.
We got to plug them in. Now, I know that you might be thinking this looks awful to have these fractions, but I promise you, it turns out to be just fine.
I already did mathematics.
So we plug in 4/3. We have to square it. That means that we take it multiplied by itself.
So 2. I mean, yeah, 16.
16 over
9.
9. Now, what's nice about this is if we are great with our fractions, what's going to happen with those 9s?
They're gonna cancel out.
They cancel out. And what are we left with? A 16. How handy did that one work? It sure did.
Boy, boy.
Then we have to plug in the other one. A negative 4/3 squared. What happens when we take a negative times a negative?
Hey,
It becomes a positive, which means, yes, Cody, it becomes the same problem.
isn't that nifty?
So is this one going to work?
Yes.
Yes, it sure does. So these are both the correct answers.